based on the definition of a radian, 360 degrees is equal to 2 pi. And more specifically, the conversion that we are going to use is that pi radians is equal to 180 degrees. Oh my goodness, I'm struggling. Alright, so this is what we need to know as we move forward. So first thing I want to do is just practice converting back and forth between the two. Remember, from now on, if you don't put units, what am I assuming you are talking about? Radians. So if you are talking about degrees, put a degree symbol. Okay, so if I want to change 45 degrees into radians, we've done unit conversions before. I might say we have, 2 revolutions per minute. And if you wanted to change that into seconds, what did we do? Right. So the same idea is here. I have degrees, I want to get rid of them, and I want radians. And I know that pi radians is equal to 180 degrees. Why did I put my degrees on the bottom? So they cancel. You can write the word radian, but you do not have to. When you're converting this, you could choose to multiply out the pi. I try to avoid that whenever possible. So all you really have to do is 45 over 180, and then we'll tack the pi back on at the end. Fractions are preferred if they come out next. So 45 over 180 is 1/4. So I try to avoid putting the pi in because pi is an irrational number. It goes on forever. If we can get a nice fraction, then what I do is I only put in the 45 over 180 and then I put the pi back on my answer. So my answer would be pi over 4. Since there's no degree symbol, that is pi over 4 radians. If I have 450 degrees and I want to change it into radians, so we multiply by pi over 180. So the degrees cancel. So on your calculator, you're doing 450 divided by 180. And that's 5 over 2. So your answer would be 5 pi over 2 radians. It doesn't matter if I give you a decimal or negatives. The conversion doesn't change. So negative 78.4. We do the same thing. If I put that in my calculator, negative 78.4 divided by 180. The fraction is not as pretty on this one, but it does turn into a fraction. Negative 98 over 225. If you wanted a decimal, or if I asked for one, all you have to do is multiply out the pi as well. And you don't use 3.14, use the pi button on the calculator if you're doing that. So I could also say this is about negative 1.3683. That's also correct. Are we okay on those conversions? Let's go the other way. I want to change these 2 degrees. And I apologize for the way they're typed. This is pi divided by 6. Keep in mind, it's really tempting a lot of times when we're looking at radians, they have a pi in it. But it doesn't have to. You're not looking to see if it has a pi or not. You're looking to see does it have a degree symbol or not. This doesn't have a degree symbol, so that's radians. So if I want degrees, what would I multiply by? 180 over pi. We just flip our fraction. So my pi's drop. So I'm left with 180 divided by 6, which is 30. If I write that, it's wrong. Why? Degrees. What's your degree symbol? 4 pi over 2. So multiply by 180 over pi. Pi's cancel, so I have 4 times 180 divided by 3. Degrees. Negative 4.5. Again, this doesn't have a pi, but that doesn't mean it's degrees. There's no degree symbol. So this is radians. We want degrees, so I multiply by 180 over pi. Different ways you could write this one. This is like negative 4.5 over 1. So you can do negative 4.5 times 180. And you get negative 810. You can write it as negative 810 divided by pi. Or you could go ahead and actually divide it by pi. And that's negative 257.831. So those are just a matter of if you keep it in terms of pi or not. Any issues with that? So what I'm going to do now is give you a circle. So in this chapter, we are going to be talking a lot about the unit circle. All right, this is a unit circle, just meaning a circle with a radius of 1. Okay, it's centered at, the center of this is 0, 0, and then radius of 1 in each direction. See, looking at the ceiling already. We're not doing the entire circle today. We're just going to talk about 2 components of it, degrees and radians. And eventually, we will add ordered pairs to that, but not for a few more days. Okay. So first, let's talk about degree measures. We know that if we go all the way around the circle, how many degrees is that? 360. Okay, so if I start here, I could call this 0 degrees. I could also call it 360, couldn't I? You go all the way around. I don't care. We'll have some of these as quizzes eventually, not for a while. I don't care if you put 0 or 360 there. They're the same thing all the way around. What would the positive y-axis represent? 90 degrees. What about this line right here? Down here? These other lines is related to our hand trick. So think about the important angles. We've talked about 0, 30, 45, 60, and 90. So these are my 30, 45, and 60 degree angles. The rest of the circle is related to this. If I'm talking about this angle down here, okay, this would be a reference angle of 30. So can you tell me what that whole measure would be? 150. You did 180 minus 30, and you got 150. Okay. This would be a reference angle of 45. So what would we do? 45. So it's a reference angle of 60, or 60 degrees from the x-axis, so 180 minus 60, 120. All right, what do I do for the third quadrant? Add. So 180 plus 30, 210. 180 plus 45, 225. 180 plus 60 is 240. Now, remember, reference angle is how far you are from the x-axis. So if I'm all the way over here, this is 30 degrees from my x-axis. How do I get that full thing? Minus 30 is 330. 360 minus 45 is 315. 360 minus 60 is 300. First, I want to point out something. As you go around your circle, what happens to your angles? They're getting bigger. Okay, they go in order. These are actual degree measures, so they get larger as you go around. Second thing I want to point out. All of these yellow lines here have a reference angle of 30, because they're all 30 degrees from the x-axis. All of these are 45 degrees from the x-axis. If I do these orange ones, those are reference angles of 60, because they are 60 degrees from the x-axis. Does everyone understand where I got my degree measures from on this circle? So we're going to use the circle to kind of help us. I'm not giving it to you to try to give you one more thing to learn. It's just another way that we can think about the hand trick. Okay, so we will be talking about this in the chapter. Honestly, if you're good at quadrants and reference angles, there is nothing I'm going to show you on this unit circle that you can't already do from what I've taught you. Okay, this is just another resource we have to help us along the way. The second thing I want to add today is the radian measure for all of these angles. Now, we know to get the radian measure, we should just do our degree measurement times pi over 180, right? We've already converted to radians. So we're going to keep them all in terms of pi. So really what we're just going to do is divide these by 180, and that would give us our radian. Okay. So 0 degrees. What's 0 times pi over 180? 0. 0 degrees is 0 radians. What would be another way you could write it? 360 degrees is how many radians? You did 360 times pi over 180. So that's 2 pi. Again, you don't have to put both of them there. I'm just showing you they are the same. So either one is fine. Okay, 30 degrees. So if you did 30 degrees times pi over 180. So it's 30 over 180. What's that reduced to? So we'll write that as pi divided by 6. All right, 45. Should get 1/4, so we'll write that as pi divided by 4. 60. So pi divided by 3. 90 times pi over 180. 1/2. So that's pi divided by 2. Is everybody with me? If I lost anyone. If you don't know where I'm getting these, please tell me now. keep doing that. Let's see what we get. So 120. 2/6. Alright, 135. What do we get? 150. 180. That's just one pie. Alright, let's divvy it up. We all know how we're getting these, right? So, once you girls do 210, you girls do 225, do 240 at this table, you three do 270, do 300, 315, 330. So what did my 210 people get? 225. 240. 270. 300. 315. And 330.
11 pi over 6.
Okay. So let's talk about this for a second. What does this help you with? First of all, it's a really nice visual. If I say 7 pi over 6, you can look at this and say, oh, that's the same thing as 210 degrees. And I can look at it and say, oh, it's in the third quadrant, so tangent would be negative and everything else, or sorry, tangent would be positive and the others would be negative. So it kind of gives you a visual on which things go together. This is also really full of patterns. If you look at these denominators, 6, 4, 3, 2, as our angle's getting larger, what's happening to the denominator? Okay, let's look. All of these reference angle of 6 or of 30. So pi over 6, 5 pi over 6, 7 pi over 6, 11 pi over 6. Their denominator is always 6. So when I see a fraction with a denominator of 6, I'm automatically thinking, oh, that's a reference angle of 30 degrees. When we're talking about the 45s, what's your denominator always? A 4. When you're talking about a 60-degree reference angle, your denominator is always 3. Okay. On the others, we're looking at denominators of 2. 0, 1 half, 2 halves is 1, 3 halves. Okay, so the denominator in radian form is really a big clue to our reference angle. We don't even really need to look at the top if we're worried about our reference angle. There's also some other patterns. If you look in the first quadrant, what's the numerator on all of those? Just a pi, so 1 pi. Okay, let's look in the second quadrant. We had 5 over 6, 3 over 4, 2 over 3. If I know the bottom, how can I get the top? It's 1 smaller. 6 minus 1 is 5. 4 minus 1 is 3. 3 minus 1 is 2. What about in the third quadrant? 1 bigger. 7 over 6. 5 over 4. 4 over 3. Okay, fourth quadrant. Can we pick out the pattern there? It's not as obvious. They're all odd numbers. What if I add 1 to these? 12, 8, 6. How are those related to the bottom? So it's basically if you take the bottom times 2 and subtract 1. Because think about, we got our degrees by doing 360 minus something, In radians, that would be 2 pi minus. So it's like double minus 1. So some people like absolutely love the unit circle. Probably nobody does today. But as we go through this chapter and we use it a lot, you might be one of those people that this really clicks for them. And I will have blank unit circles on every test and quiz that we take, that if you want one, if it helps you, you can take one at any time and fill it out. Because some people, this really makes sense to them and it helps them keep track of things. Right now, all I'm worried about, I want to make sure you understand how I got my degree in radian measures. And I want you to understand that when I say 5 pi over 4, that is the exact same thing as saying 225 degrees. And do you guys know how to go back and forth between the two? Either multiply by pi over 180 or 180 over pi. Alright, so the last thing I want to do today is just practice evaluating our trig functions. So the same things that we've done before, but I'm going to give you a radian measure. So instead of saying the sine of 45 degrees, I'm going to say find the sine of pi over 6. Now, some people, like especially at first, I know the temptation is probably just to convert that into degrees. And while that is absolutely 100% okay, my goal is for you to get comfortable enough with radian measure that you don't have to automatically grab the calculator and take it times 180 over pi. Okay? So when I'm looking at this, I'm thinking, okay, my denominator is 6, so what does that tell me? It's a 30-degree angle. My numerator is just 1 pi, so what quadrant are we in? 1. So I know this is quadrant 1. My reference angle is 30 degrees. In the first quadrant, is sine positive or negative? Positive. And what is the sine of 30 degrees? 1/2. Back to our thinking. Cosine of 3 pi over 4. Alright, so when I look at this, what quadrant is that in? Okay, 2. I know that because the top is 1 less than the bottom. For your reference angle, you really ignore the top, it's just pi over 4. And if it's pi over 4, what is that? 45 degrees. Now, if you don't recognize that yet, that's okay. We're working on that. We're getting there. We're practicing. So in quadrant 2, is cosine positive or negative? Negative. What is the cosine of 45 degrees? Tangent of 5 pi over 3. What quadrant is 5 pi over 3? 4. Double minus 1. 2 times 3 is 6, minus 1 is 5. So this is quadrant 4. Reference angle. Alright, you're just looking at pi over 3, that's 60 degrees. So in quadrant 4, is tangent positive or negative? Positive. Negative. All students take calculus. Cosine's positive, so tangent would be a negative. What's the tangent of 60? Square root of 3 over square root of 1, so square root of 3. Let me throw one more up here. What if I said secant of maybe 17 pi over 6? I can probably look at that, or I should be able to look at that and tell the reference angle right away. What's my reference angle? 30 degrees, because it's over 6. Now the quadrant is a little trickier, but think back. If I give you a negative degree measure, what did we do to that? We have 360 degrees. Okay, in radians, 360 degrees is the same as 2 pi. So we're going to start out just adding 2 pi to this. Now, when you do it on your calculator, don't put in the pi. So you just have negative 17 over 6 plus 2. And that's still negative, right? So we do it again. So plus 2. And what do we get? What quadrant is 7 pi over 6 in? Reference angle we already said was 30 degrees. So in quadrant 3, secant, that's the reciprocal of cosine. Is that positive or negative? Well, students take tangent will be positive, so this is negative. Okay. So cosine of 30 is radical 3 over 2. So secant, if you flip it, is 2 over radical 3 or negative 2 radical 3 over 2. So if you got steps, you absolutely could multiply this by 180 over pi to start with and deal with the degrees. We're just going to work on getting comfortable with the radians as well, though. Okay? So that's all I have for you. Please pay close attention here. 60 or 30 through 62, every other even. So just remember what that means. Let me